today. It's the same thing as yesterday. So if you want to give these 4 a shot, they're also the first 4 in your homework if you want to look at that um, while I finish setting things up. It's the same. It's the same approach. It's just with metric units. So if you don't know metric stuff, which I'm pretty sure we went over metric at the beginning of the year in science. Is this from yesterday or today, Catherine? From yesterday? Yeah, I can do that. I just gotta look it up what it is. Number 5 from yesterday. So this is yesterday. This is page 216, number 5. We're going 13 hours to minutes. So I want to take 13 hours a minute, so again I'm going to put that as 13 hours over 1. So this is my given. This is what's given to me. And I'm going to multiply it by conversion ratios. I don't know what it is, but I know hours has to go on the bottom. So they cancel out. Then you look at, well, or use your common sense. I don't know if it's up there or not. Yeah, it tells you that there are 1 hour is 60 minutes. So minutes would go on top. And you have 60 of those in 1 hour. So then you do 13 times 60. What's 780? Minutes. So it's going to be 780, technically over 1, but 1 times 1 is 1. 13 times 60 is 780. There's nothing on the bottom except for the 1, so you don't need it. It's just 780 minutes. That's all you're doing. This here is your conversion ratio, or conversion factor, whatever you want to call it. That's pretty easy. So if you have questions about yesterday, you can ask them now, or give 1 through 4 a shot on your homework right now before I do it. And that way you can see if you're doing these right. Just check what you're doing. And then we'll do a little more complicated ones today that will help prepare you for later in the week when I start giving you things more complicated than the book does. Because the book doesn't do too good of a job here. Number 7. This is also from yesterday, Catherine. Page 216, number 7 is 4320 seconds, 2 hours. This one you probably have to do in a couple steps because you don't know how many seconds are in an hour, probably off the top of your head, or maybe you do because it's not too difficult to figure out. But we're going from seconds to hours here. So again, this is our given. There is no denominator, so we're just going to call it 1. Multiply by conversion ratio, and the denominator has to be seconds. If you know how many seconds are an hour, you can use that conversion ratio, but most people probably don't know that off the top of their head, and they probably have to do some math. Or you can use seconds to minutes first. So let's take it to minutes, and you know there are 60 seconds in 1 minute. This way seconds will cancel, but it wants us to go to hours, so we're going to multiply it by another conversion ratio. And in this case, we want minutes to cancel because seconds already canceled. We want minutes to cancel, so minutes will go on the bottom. And do you know a relationship between minutes and hours? Hopefully you do. So hours will be on top, and you know there are 60 minutes in 1 hour. So then when you do your numerator here, you did 4,320 times 1 gives you 4,320. And this unit, these minutes canceled, your units on top is hours. On the bottom, you have 60 times 6. Excuse me, you have 60 times 60, which is 3,600. In that case, you don't have any units on the bottom. They all cancel. Ugh. So in this case, you just reduce this fraction here. Right away, we can divide each by 10. I'm going to come down here and just reduce it. 3. Again, you can divide by 10. You can knock off the 2 zeros here. Over 360. I don't know what else goes into these. Obviously, 4 does. But I don't know what it is off the top of my head, so I'm just going to grab the calculator and turn into a decimal. And you get 1.2. I just divided that out. That's hours. Because if you want that as a fraction, it would be 1 1/5 hours. I don't know. Alright, let's look at the first 4 you were doing over here. These are actually the first 4 in your homework as well. So if you're looking at your homework page on 218, so this is from page workbook 218. Here we're going from grams to kilograms. So again, you're going to start off with what you know. Make it a fraction. You don't have a denominator unit here. So that's going to be your first ratio. Then you're just going to multiply it by conversion ratios. You probably should know how many grams are in a kilogram. If not, I think it actually gives it to you at the top. Yeah, it says 1 kilogram is 1,000 grams. So we know grams has to be on the bottom so they can cancel. And 1,000 of these is 1 of these. And that's kilograms, so that works out how we want it. So this is going to be 300 times 1, which would be 300, over 1 times 1,000, which would be 1,000. You can reduce that. Again, you can knock off 2 zeros and you get 3/10, which is acceptable if you want to leave it as that, or you could put it as 3/10. And then your units, your grams here are canceled, so you're left with kilograms. So that would be an answer, or if you want to put kilograms there, that'll be an answer. No, it tells you what a metric ton is, doesn't it? Yeah, it says 1 metric ton equals 1,000 kilograms. And it abbreviates metric ton as the T. So it really says 1 lowercase t equals 1,000 kilograms. That's what you would use for this one. Again, this is coming from the table on the page. You look these up or you have them memorized. But over here, same process. It's going to be 0.75 tons over 1 because we don't have a denominator here. and we want that tons to cancel, and we want to turn it into kilograms. Looking at the table, do we have something that relates to that? Yes, that's this right here. So I can relate that to kilograms and have my tons cancel, and I know 1 ton is 1,000 kilograms. Is that what it was? Yeah, 1,000 kilograms. In that case, this is going to equal this times 1,000, which you'll note you're just moving a decimal point when you multiply with the metric system. So you'll note how we have nice numbers with a bunch of zeros at the end. Right. So multiplying by 1,000, that's 1230. So you move the decimal point 3 times. That's 750 kilograms. And then you're obviously your tons are going to cancel, and you're going to be left with 1 on the denominator here, but we don't write it. We can simplify that. So that would be your answer. Over here, you're going from kilograms to milligrams. I don't know if we have a jump like that. I think you have to take it a couple steps here, unless you know how many are in there. Yeah, it looks like you're taking it a couple steps here. So here again, you're going to start with what you're given. So 0.035 kilograms. We don't have a denominator because it's not a rate. Your next fraction has to cancel out kilograms, and you want to go towards milligrams. We don't know milligrams though, so you're going to have to go to grams first. So we take that to grams, and it tells you that there are 1,000 grams in 1 kilogram. So we have 1,000 grams in 1 kilogram. If we stopped there, our answer would be in grams, which we don't want. So we need to get rid of grams. Grams is on top here, so we're going to get rid of it on the bottom here. And you'll note kilograms are going to cancel, and now grams will cancel. And we know that there are 1,000. And again, looking at the top of the table is where you're getting this. Yeah, it's up there. Milligrams in 1 gram. And now grams will cancel. Leaves you with a unit of milligrams on top. And there are no units on the bottom. In fact, 1 times 1 times 1 leaves you with 1 on the bottom, so you don't even have a denominator. And then you just multiply it out. And again, you're just moving decimal points when it happens. There's 1, 2, 3, 4, 5, 6 zeros here. So what you're really doing is 0, 3, 5, 1, 2, 3, 4, 5, 6. Fill in your place values, and you get 35,000. 35,000, or you can use a calculator. I don't really care. It doesn't matter to me as long as you're getting the right answer. I'm assuming you know how to multiply by now. Milligrams. Kiloliters to liters, same deal. It's just in capacity now. So we are doing volume as opposed to, what is this, mass? So over here, this is volume. So we have 8 kiloliters. Keep in mind that the abbreviation for liters is a capital L. You should not be writing lowercase l's. A lot of people make that mistake. And I want kiloliter to cancel, and I'm going to liters. So again, looking it up, I know there are 1,000 liters in 1 kiloliter. That, again, coming from the top of the page, that's our conversion ratio. And you just multiply it out. 8 times 1,000 is 8,000. Kiloliters is going to cancel. 1 times 1 is 1, and you're left with liters on top. So this is 8,000 liters. Are there any questions on how to do this? Hopefully that's getting down a little better. I'm going to pull up some tougher ones to look at now, if there aren't any questions, just to get you used to doing some kind of other things. Maybe you don't actually know your conversions to some things and you have to look them up somewhere. You do have the internet to do that. You're not always given everything you need, so you got to look some things up. So I'll do a couple tougher ones that deal with some rates here. I got to find some rates though, like density. I think we'll do density. So you should know that our formula for density is density. Well, you don't know this rho. density equals mass divided by volume. This is our formula for density. So if you want to actually find a density, your units would be a unit for mass divided by a unit for volume. For example, you could have a density of 4.52 grams per milliliter, right? Grams measures a mass, milliliters measures a volume. So this here is a unit for density. So this is a density unit. It's a compound unit. There's more things. You're probably more familiar with maybe speed as a compound unit. Your speed could be like 25 miles per hour. You'll note that your units have a numerator and denominator to them. But we're in the metric system, so we're going to use density right now. So this here is a density. And what if I wanted this, instead of being in grams per milliliter, what if I wanted this in kilograms per liter? Right? In that case, I'm changing both my units. I'm changing grams to kilograms and milliliters to liters. So let's do this problem. Again, the number, don't be confused with the number. It's just a number we picked. We'll deal with the number when it comes to math. If you can multiply by it and divide with it, it'll work. You might want to write this down, Catherine. Again, I'm just going to show you one where you deal with denominators and stuff like that, because you are going to get it, and your book doesn't get too far into it. And it is important to know, because most units are derived units. They are compound units. You're measuring, even like area is going to be like centimeters squared. That's technically a compound unit. Volume would be centimeters cubed. Right? So we do have those units, and we use them a lot. In science, you've probably figured out the Newton is a kilogram per, what is it, a force? Force equals mass times acceleration. A kilogram times a meter per second squared. That's a Newton. It's this unit here. We just get tired of writing that, so we write capital N. But here we have density, so we're going to write our given. Just be careful how you do it. It is a rate unit, so grams is on top and milliliters is on the bottom. And it is technically written, or you can technically say that this is 4.52 grams for every 1 milliliter. So your denominator still has that 1 in it. Centimeters squared as a fraction. It's just centimeters squared over 1. It's not a fraction, it's a compound unit though. It's centimeters times centimeters. Here, this is our given. So hopefully you should be able to pick out your given with this. And you just got to pay attention to your units. We want to take it to kilometers per liter. So we got to pick one to start with. It does not matter the order that you do these in, as long as you do them. We can either get rid of grams first or get rid of milliliters first. Let's go ahead and get rid of milliliters first, because it's on the bottom. We haven't done things like that. So we're going to get rid of milliliters first. We want milliliters to be liters, so we need it to cancel. In order to cancel, we got to put it on top this time. So it's not just always putting things on the bottom. It's going to be putting it where it's going to cancel. So here milliliters will cancel, and I need to find a relationship between milliliters and something else, hopefully liters. And I think your book gives you that one, and it tells you that 1 liter is 1,000 milliliters. Okay, so now if I were to stop there, my milliliters will cancel, and my units are going to be in grams on top and liters on the bottom. So this will be grams per liter. I don't want that. I want kilograms per liter, but it's a step closer. So then I'm going to tack on another conversion ratio. And in this one, I need grams to cancel. If grams is on top, I need grams to go on the bottom in order to cancel. And do you know a relationship between grams and kilograms? I believe your book does give you that there's 1,000 grams in 1 kilogram. So in this case, grams are going to cancel. And here, one of your beauties of the metric system is going to come out. In the fact that everything's by groups of 10. So here you're going to get technically this times this, but these you could probably cancel. If you notice that, hey, this and this is 1, you could cancel that out. So your number is going to be 4.52. But your units changed. You now have kilograms per liter. So you got larger units on things. But it's the same scale of it. So it really didn't change the number value, but you did change your kilograms per liter. You'll note that all what you did was take your numerator and multiply it by the same value as you did your denominator. So it didn't really change your number at all. So that is your answer there. It does kind of just cancel things out a bit. It makes it nice for the metric system that way because everything's in powers of 10. That doesn't always work in the US system, but in this way it does. Let me see if I can find another one. I don't know if we did scientific notation this year or not, but let's do an interesting one. What if I told you, let's do a speed one. What if I told you that the speed of light in a vacuum, how do we spell vacuum, is 3.0 times 10 to the 10th centimeters per second. Again, the number value doesn't matter. It's more about the units that we're following here. And I want to know what this is in, let's do kilometers per hour. Kilometers per hour. So what is this in kilometers per hour? Let's take this number, the speed of light, and measure it in kilometers per hour. That'll be fun. We'll try the math with it. I don't know how comfortable you are with scientific notation, but bottom line is this scientific notation makes life easier for you, so you might as well use it. So we're going to start with our given, which is 3.0 times 10 to the 10th centimeters over 1 second. And we want to take centimeters to kilometers and seconds to hours. So let's start with seconds, because we did one similar to this yesterday, and I think earlier today, actually, yeah. So we want seconds to cancel, so we're going to put seconds on top. And do we know how many seconds are in an hour? Probably not. You probably know how many seconds are in a minute, though. So that can be our first conversion ratio, and we know there are 60 seconds in 1 minute. And again, you look those up if you don't know it. In this case, our seconds are going to cancel. And now we're going to be centimeters per minute, getting closer to kilometers per hour. Next, let's get rid of our minutes. Again, minutes need to cancel. I can take minutes to hours because I know there are 60 minutes in 1 hour. Now my minutes are going to cancel. Now, if I were to stop here and do my math following my units, I would have centimeters on top and hours on the bottom. So this would answer centimeters per hour, which is closer, but it's not kilometers per hour. I don't think your book actually gives you centimeters in a kilometer. That might be something you look up, but I'm going to tell you there are 100 centimeters in 1 kilometer. Is that right? No. It's 100 centimeters in 1 meter. There's 1,000 Yeah, it gives it to you in meters. Yeah, there's 100 centimeters in 1 meter. I think it gives it to you in meters. Can I go from 1,000 to trying to just do it based off of what it gives you? Yeah, it gives it to you on page 216 actually. So it gives you 100 centimeters in 1 meter and 1,000 meters in 1 kilometer. So those are the two you need. It just gives it to you on page 217. Again, there are things you'll look up if you don't know off the top of your head. So we're going to multiply by those conversion ratios. We need centimeters to cancel here, so we're going to put centimeters on the bottom. I can take centimeters to meters, so I'll put meters on top. I know there are 100 centimeters in 1 meter, so 100 goes with centimeters, 1 goes with meter. Now my centimeters are going to cancel, and if I were to stop there, I would get meters per hour. I got meters on top, hours on the bottom. I want kilometers per hour, so we got to get rid of that meters as well. So meters will go there, and I know there's 1,000 meters in 1 kilometer, so I can take that to kilometers. 1,000 goes with the meters, and 1 goes with the kilometer. Once we have that, we are set, and we can actually solve this. It's actually not too bad to do in your head, but you might not like scientific notation here. But what we're going to do is we're going to take 3. I'm just going to take the number 3 right now because we're going to multiply by a scientific. I'm going to ignore the exponent. I'm just going to tack it on at the end. So I'm going to take 3 times 60 times 60. Which, if you want to use a calculator for it, you can. I don't blame you right now. 3 times 60 times 60 gives us 10800. And I didn't multiply by this times 10 to the 10th, so I'm just going to tack it on times 10 to the 10th. All over, and then 1 times 1 times 1 times 100 times 1,000 gives you 1,000 with 2 zeros. So what is that, 100,000? Now, I don't know how great you are with exponents and powers of 10, but each power of 10 is being multiplied by a 10. So there's 1, 2, 3, 4, 5 powers of 10 here. This is, in other words, how many zeros is that? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 equals 10 to the 5th. So I am going to take off 5 of my exponents when I divide. That's how those are going to come out. So this is going to equal 10800 times 10 to the 5th. And you can leave it like that. And your units, don't forget your units. Meters here cancel, so you are in kilometers per hour. Technically that's bad scientific notation, but we're not getting into scientific notation today. But the process is the same, no matter what the number is. Even if it's a number you don't quite understand, it's still done the same way. You multiply your numerators, get your numerator, multiply your denominators, get your denominator, and divide. Number 11. Yeah, we did a couple tough ones. We can answer questions on that. What does number 11 say? Oh, well, I mean, that's your choice. This is an opinion question, Kelsey, if you want. Most of the countries in the world use the metric system as an official system of measurement. Why do you suppose this is the case? Do you prefer to work with the customary system or the metric system? Explain. Again, for number 11, it's kind of your choice. Just make it your, just explain why you chose that. For example, the metric system is all in powers of 10, so the math is easy to do in your head, right? I mean, when you were looking at the ones we were doing, you were just moving decimal points or adding zeros to things. So I mean, that's like the case for the metric system. Maybe you like the custom system better, which is what you're probably used to. Because you know what? I live in the US and everything is in this system. Right? Your car measures miles per hour, not kilometers per hour. I mean, that's what you use. No, actually the answer was 10800 times 10 to the 5th kilometers per hour. Yeah. Yeah, that's what it is. Yeah. Don't forget the exponent. In later years, we'll talk more scientific notation. It actually is pretty simple and makes your life easier because it is just based off of groups of 10. And that's why most of the world likes the metric system, because we live in a base 10 system, so anything with an exponent of 10 is really easy to work with. Number 7. $22 grams compared to 2.2 kilograms. Alright. Well, if you know your conversion table, you know that there are 1,000 grams equals 1 kilogram. Then it's pretty clear that that's bigger, because 22 is not even close to 1,000, and this is over 1 kilogram. But if you want to convert it, you can. So let's take 22 grams and make them kilograms. You know that there are 1,000 grams in 1 kilogram. Again, grams need to cancel, so you're going to get 22 over 1,000, which is equal to 0.022 kilograms. So this is actually equal to 0.022 kilograms. And then that one's clearly larger. You just got to make sure they're both in the same units. You could have brought this to grams. We can do that really quickly. If I want to turn that into grams, I need kilograms to cancel. And I know there are 1,000 grams in 1 kilogram. This is going to equal 2.2. This is that 1, 2, 3. 1, 2, 3. $2,200 grams. And then you know. You can either compare the grams together or your kilograms together. Either way, this is the larger one. Any other questions about yesterday's, about today's? Hopefully you're getting the hang of it. It's really all the same thing. Just watch your units. But dimensional analysis works really well, especially when numbers get kind of ugly and you got to keep track of things. You can use it a lot in chemistry class when you get to moles. I don't know if I ever told you about Avogadro's number or not. Same as what you just kind of asked me, which was 28 fluid ounces. Don't confuse a fluid ounce with an ounce. They are very different things. And 3 cups. You either got to make this fluid ounces into cups, or you're going to make this cups into fluid ounces. So let's just, it gave you fluid ounces first. Let's move that into cups. So let's take fluid ounces and make it into cups. We want fluid ounces to cancel, so that's on the bottom. Then you're going to go look for a conversion, if we have one. Yeah, it gives it to you on page 215 though. It says on 215, it says 1 cup equals 8 fluid ounces. So 8 fluid ounces in 1 cup equals 28 divided by 8. Again, fluid ounces are going to cancel. Yours is going to be cups. How many times does 8 go into 28? At least 3 times, right? That's 3, and then there's some left over, so you know that's going to be larger. But I could get you an actual number here. I can divide each by, I don't know, just divide it out. 28 divided by 8 gives you 3.5. So this is equal to 3.5 cups. You got to compare cups to cups. You don't need notes, it's the same thing. So whatever I gave you yesterday is what really is all about. We're just practicing it and doing more of it. 1 mole is equal to 6.02 times 10 to the 23rd. And this is how many atoms of carbon are in 1 gram of carbon. So a mole is a count of atoms in chemistry. But if you have any other questions, now's a good time. Clarification on anything. Tomorrow we're going to look into converting between US and the metric system, which again is really the same thing, and you're just going to be looking up the conversion ratios. It's just that these ratios are probably not nice ones that you have memorized. I don't have a lot of those ones memorized either, so. How to use conversion factors to convert units. That's what we've been doing, so it is dimensional analysis. However you spell that. This is dimensional analysis, and you're just going to be multiplying them. You multiply your given by the factor. So units cancel. You need to make sure units are going to cancel and things. So something along those lines, Catherine. Yeah, metric to customary tomorrow. So it's going to be like, hey, you have, I don't know, 16 inches equals how many meters? Right? Inches is one system, meters is another system. They don't necessarily, I mean, there is a conversion between them, but you don't normally see inches and meters mixed. So you want to change it to one or the other. And again, you just look up the conversion ratio. Like I know I thought we had 1 inch equals 2.54 centimeters. So there's a conversion ratio there. That's a 1. I can't write very well today. And then you can take this to centimeters, and you take centimeters to meters. It'll be fine. Yeah. For page, this was yesterday's homework though, page 216. 218 doesn't have a number 15. But yeah, just explain what we did. You multiply. Just make sure your units are canceling. Any other questions? Alright, if you have more questions, feel free to email me, and I'll get back to you in a reasonable time, hopefully. Alright, I'm going to end it there. Talk to you guys tomorrow.